Hello friends, welcome to today's lesson. In today's lesson, we'll be learning about linear equations. If you are new to this channel, please like, subscribe, press the bell icon so you can be notified automatically whenever a new video is released. In order to understand linear equations, we'll first of all take a quick introduction into linear equations. Thereafter, we'll learn how to solve linear equations. So as a way of introduction, a linear equation is a mathematical statement in which the highest power of the variable is 1 and the left-hand side is equal to the right-hand side. Take note of these two keywords, power and variable. What are variables? Variables are the alphabets in an equation. What is power? Power is the index to which a variable or constant is raised. So a constant is the number you see in an equation. So the numbers you see in equations are referred to as constants, while the alphabets are referred to as variables. For example, in m squared, the power of m is 2. That is because m is raised to the index 2. In x, the power of x is invisible 1. In other words, this is the same thing as saying x raised to power 1. Just the same way we have m raised to power 2. But the reason why we did not write a 1 to the power of x is because in mathematics, we don't like writing 1 when it comes to power and coefficients. Linear equations produce a straight line when plotted on a graph. This is one of the important criteria of linear equation. When you plot a graph of the y-axis versus the x-axis in a linear equation, you will have a straight line. Hence the reason why they are called linear equations, because the word linear simply means straight. So whenever you see a straight line graph, just know that it's a linear equation. Examples of linear equations are 3n plus 7 equals to 15, 5n minus 9 equals to 4n plus 25, and 3x plus 2 equals to 8x plus 10. These are just examples of linear equations. And I've brought out these examples so that we can see the peculiar characteristics of linear equations. One of the criteria for an equation to be linear is that the variable, the highest power of the variable, should not be greater than 1. So like in this case of number 1 equation, the variable here is what? M. Take note that 7 and 15 are referred to as constants because they are numbers. So m in this case is a variable. And as you can see, the power of m in this case is an invisible 1. So since the highest power of the variable in this equation is 1, this is a linear equation. Okay? Moving to the second equation, we have 5n minus 9 equals to 4n plus 25. The variable in this case is letter n. Letter n on the left-hand side and letter n on the right-hand side. Take note that in an equation, the equality sign divides the equation into two parts, which are the left-hand side and the right-hand side. Okay? So now, talking about the variable n, which we have in this number 2, in this number 2 example, we can see that the highest power of n is an invisible 1, and the highest power of n on the right-hand side is also an invisible 1. So for the fact that the highest power of the variable we are considering in this case is 1, it therefore makes this equation a linear equation. Similarly, in this example 3, the variable in this case is x on the left-hand side of the equation and x on the right-hand side of the equation. The highest power of the variable is 1, both on the left-hand side and on the right-hand side. So this is a linear equation for sure. So what have we learned so far? We've learned that the alphabets in an equation are referred to as variables, the numbers are referred to as constants, and when the highest power of the variables in an equation is 1, that equation can be referred to as a linear equation. Bravo! Some other types of equations we will learn later are quadratic equations and simultaneous equations. Okay, prerequisite knowledge. Prerequisite knowledge simply means the knowledge you would have to have in order to have a good understanding of today's lesson. Okay? So one of the such knowledge you have to have is that you can only add or subtract similar items. This is what I mean. Examples. We have 3m plus 2m. Because they are similar items, when you add them up, you will have a result. It's like you likening letter M to be mango. 3 mangoes plus 2 mangoes, you know it will give you 5 mangoes, right? Yes. But when you have items that are not similar, let's say 3m plus 2m, you cannot add them because the rule says you can only add or subtract similar items. So it will remain as 3m plus 2m. Okay, it's like saying 3 mangoes plus 2 nails. It will remain as 3 mangoes plus 2 nails. Okay, this similarly, when we have 5a minus 2a, it's like you saying 5 apples minus 2 apples. What are you going to have? 3 apples. So 5a minus 2a is 3a. However, 5a minus 2m, because they are not similar, you cannot subtract them. You will just leave your answer as 5a minus 2m. Very good. Multiplication freezes things. Yes. Whenever you see two items frozen, let's say xy, 3m, it simply means they have been multiplied. Okay. Now, example, if we have 3 times m, because of this multiplication, 3 and m will become frozen. So we'll have 3m. Okay. Similarly, when we have 1 times y, we'll have what? 1y. But in mathematics, just like I've said earlier on, we don't like writing 1 when it comes to coefficient and when it comes to power. Take note, the number that is frozen to an alphabet is referred to as the coefficient of that alphabet. In other words, in this first example here, the coefficient of m is 3. That is the number or alphabet that has been frozen to the variable we are considering. Okay, so in this second example, the coefficient of y is what? 1, an invisible 1. Okay, all right, let's move ahead. For other important math facts, you can check my Mathematics Made Easy series, which is on my playlist. Okay, all right, now we'll learn how to solve equations. Okay, that is why this is termed solving linear equations, and we'll learn by solving examples. Okay, so solve the following equations. The first example we have here is 10y minus 8 equals to 27. The first thing you'll have to ask yourself is, what type of equation is this? Does it meet the requirements for it to be a linear equation? Now let's check. What is the variable in this case? The variable in this example is what? Letter y. Very good, very good. What is the power of y in this case? The power of y in this case is an invisible 1. That is the reason why it is not written. If y was to have any other power other than 1, it must be written. Okay, even if it is minus 1, minus 2, it must be written. But when it is 1, it will not be written. So for y to have stood alone without a power, it simply means the power of y is what? 1. So because the highest power of our variable is 1, this is a linear equation. Okay, and take note that the 8 and 27 are constants. So now, how do we solve this equation? When you are faced with an equation like this, the first thing you want to do is to write your solution, reproduce the same equation you have been given. The next thing you do is to what? Collect like terms. What are like terms? Like terms are numbers and numbers, or variables that are the same. You bring them together. So in this case, our like terms are constants. Okay, constants are like terms, so you bring them together. Okay, and we always prefer a situation whereby we'll have our constants on our right hand side. Remember, we said this equation divides this equality sign divides an equation into two parts, which is the what? The left hand side and the what? The right hand side. So we prefer moving all constants to where? To our right hand side. Since we prefer moving constants to our right hand side, 27 is already on our right hand side, right? Yes. Is a constant, right? Yes. In other words, it will be wrong for us to move this 27 to the left-hand side. So it simply means 27 is the owner of this land. So let it remain here. It is not moving. It is going nowhere. Very good. How about 8? Is 8 not a constant? It's a constant, right? Is it on the left-hand side or the right-hand side? It is on the left-hand side. It simply means we will have to move 8 to the right-hand side, right? To go and marry up with 27, right? Yes, bravo, you're right. So 8 will have to move from the left-hand side to the right-hand side, since we are collecting what? Like terms. But you have to be very careful. You have to be very careful of something. Do you know what you have to be very careful of? It is this minus sign in front of 8. Take note that whatever sign that is in front of a number or an alphabet, be it plus or minus, that sign belongs to that constant or variable. Okay? Now, this is very, very important. Please take notes. In this equation, as you are seeing here, every variable or constant has a plus or minus sign in front of it. Let's say, for example, this 10y, it has an invisible plus. The sign in front of 10y is an invisible plus. Whenever a variable or a constant is not having a plus or minus sign in front of it, it simply means there is an invisible plus. Like in the case of this 10y, there is an invisible plus here. That is the reason why plus or minus is not written here. Like in this case, like in the case of 27, there is an invisible plus here. That is why nothing is written here. But in the case of 8, when it comes to minus, it must be written. It's a must. Okay, so that's the reason why this minus belongs to this 8. Okay, since we are collecting like terms and 8 is crossing over, it is not just 8, it is minus 8 that is crossing over to the right hand side. This is very, very important. You can see that I'm taking my time at this particular stage because it is very important you understand what is going on here. Okay, now since we have understood that it is minus 8 that is crossing from the left hand side to the right hand side, there is another thing you'll have to take note of. The thing is this: when a woman crosses this sign of equality, she changes into a man. Okay, when a man crosses the sign of equality, he changes into a woman. Okay, you can decide to use a boy or a girl. Okay, so the point I'm just trying to establish is this: when you have a minus sign crossing over either to the from left to right or from right to left, as we would see in other cases, the sign in front of it will have to change to the opposite. Okay, so if this is minus 8 and it is crossing over, it is going to become what? Thank you. It's going to become plus 8. All right, so as you can see, this 10y is the same 10y we have written here. This equality sign is the same equality sign we have written here. This 27, which was on the right hand side before now, is the same 27 that we have written here. It has not transferred to anywhere. It has not moved to anywhere. But this minus 8 that has crossed over has now become what? Plus 8. Bravo. You are doing very well. So now we have our constants together, which are like terms. Okay, so what do we do next? We just add 8 to 27. And when you add 8 to 27, you have what? 35. Okay, so we now have 10y equals to what? 35. Very good. Now, take note that we are asked to solve the following equations, right? We are asked to solve this particular equation. In other words, we want y to be alone. We want to know the value of y. That is what we are solving for, okay? But at this stage now, y is still being disturbed by what? This coefficient, which is 10. Y is still 10 is still disturbing this y. We want to free up this y so we can know its value. So what do we do at this stage? Whenever you are at this stage in mathematics, at this stage where the variable you are solving for is frozen or multiplied by a coefficient. You remember we said any number that is frozen to a variable is referred to as its coefficient, right? So in this case, the coefficient of y is what? 10. You are doing very well. So in this stage, or at this stage in mathematics, you will have to divide both sides, that is the left-hand side and the right-hand side, by the coefficient of the variable you are solving for, which is y. Okay? So I have decided to rewrite this same expression here so that we'll have a very good understanding. So you will divide both sides by the coefficient of y. What is coefficient of y? We've said that coefficient of y is the number that is frozen to y. Okay? So we'll now have 10y divided by 10 and 35 divided by 10. Just because we have already said we are dividing both sides by the coefficient of y. And the coefficient of y is what? 10. Very good. So now we have 10y divided by 10, 35 divided by 10. So this 10 will cancel this 10. Okay? So what will happen is that this 10 here would cancel this 10. So 10 in 10 is 1, 10 in 10 is 1, okay? While this 10 here would cancel this 35, okay? So we'll end up having, since 10 has cancelled 10, we end up having y equals to 35 over 10. That is what is left, right? And when 10 cancels 35, 10 will go to 35 3 times. There will be 5 remainder over 10. So what have we done? We have just converted. We could have as well left our answer here, okay, since y is now free. But the problem is that this is what we call an improper fraction. I will call it improper fraction because it is improper for 10, which is a small number, to carry 35, which is a bigger number. Just the same way it is improper for a child to carry his father. Okay, so we have to make it proper by converting it to what is referred to as a mixed fraction. I have a video dedicated to fractions on my playlist in case you are struggling with fractions. Alright, without wasting much time, let's move on. Let's take a look at this other example. We now have 5x minus 3 equals to 2x plus 12. So we start by writing out the equation we have been given. Okay, now what do we do? First of all, we have to establish that it's a linear equation. And I will be very fast this time around, okay? How do we know it's a linear equation? We know that it's a linear equation because the variable in this case is x. And the power of x is what? 1 on the left-hand side and 1 on the right-hand side. So it's a linear equation for sure. So how do we solve this linear equation? We'll start by doing what? Collecting like terms. So you have to collect like terms. As you can see, we like having our constant on our right-hand side. Plus 12 is a constant. It's already on the right-hand side, right? Very good. So we'll leave it on the right-hand side. Minus 3 is a constant, but it's on the left-hand side. So we'll have to move it to its like term, which is a constant, okay? 5x is a variable, okay? It's a coefficient and a variable. It's on the left-hand side. This 2x here is on the right-hand side. We don't want it on the right-hand side. We love moving all variables to the left and all numbers to the right. That is what we love doing. That is what you would want to do in order to solve equations, okay? Especially linear equations. So we have to collect like terms. So what will happen now is this. Since we like having our constant on our right-hand side, plus 12 will maintain the right-hand position, okay? Minus 3 will cross over and it will become what? Plus 3. Very good. Remember that 2x is crossing over to the left-hand side, right? What is it going to become? Just before you decide what it's going to become, remember that we said when a number is not having any sign, plus or minus in front of it, simply means there's an invisible plus. Okay? So when this plus 2x, when this 2x crosses over, it will become what? Minus 2x. So that's the reason why we have our 5x, which was here before. This is it. This plus 2x, which was on the right-hand side, has now crossed over. It has now become what? Minus 2x. Okay? This equality sign remains this equality sign. This 12 is what we have written here. But take note, it was plus 12 before. Now I've written only 12. So what happened to the plus? Does it mean this plus doesn't longer belong to 12? No. It still belongs to 12. What I've written here is same thing as plus 12. But the thing is this. When the first expression you are writing in an equation is having a plus sign, you don't need to write that plus sign, okay? So on this right hand side, 12 is the first expression we are writing in this case, and the sign in front of it is plus, so we don't need to write the plus. If it were a minus, I repeat again, if it were a minus, we cannot just write 12, we must write that minus sign. This is very, very important, okay? Take notes. All right, so the minus 3, which was on the left hand side before, has crossed over. It has now become what? Plus 3. Okay, good. Remember that there was a math fact we learned. One of the prerequisite knowledge we just learned. We said we can only add or subtract similar items, right? Very good. Can you see that these are similar items? You can liken letter X to be anything you like. You can liken it to be xylophone or anything. So 5 xylophones minus 2 xylophones will give you what? 3 xylophones. In other words, 5x minus 3x will give you what? 3x, okay? And 12 plus 3 will give you what? 15. I hope it's clear down to this stage, right? Very good. Remember that we have learned how to solve this stage in mathematics before now. What do we do here? We divide both sides by the coefficient of x. This time around, our variable is x. If it were any other variable or alphabet, that is exactly what we would write here, okay? And in mathematics, it's always important to show your steps. It's always important to write down key phrases like collect-like terms, divide both sides by coefficient of x. It shows that you really know what you are doing, okay? All right, so 3x equals to 15, 3x equals to 15. We have divided the left-hand side by 3, and we are dividing the what? The right-hand side by 3. Very good. So 3, we cancel 3, and we'll have what? X equals to 15 over 3. If you like, you can do your cancelling here once and for all. But I have decided to bring it down for a better understanding, okay? That when 3 cancel 3, we'll free up x. So x will be equals to what? 15 over 3. But the question now is this. Can you leave your answer like this? No, because it is improper. Okay, so we have to convert it to what? A mixed fraction. Okay, sorry, I meant to say you have to divide 3 into 15. So when 3 goes into 15, you have a what? 5. So it wouldn't even give you a mixed number, because 3 can divide 15 without any remainder. So 3 into 15 is what? 5. All right, let's move on to the next example. We have x over 10 equals to 5 over 2. Okay, so the first thing we do, okay, just before we write the step to take, okay, we have x over 10 equals to 5 over 2. The first question we'd like to ask ourselves is this a linear equation? Don't be scared. Number 1 is an equation because of this equality sign. Equation, from the word equals, okay? Equation. So this is an equation, right? Good. Now I want to establish whether it's a linear equation or not. Ask yourself, what is the variable in this case? The variable is the letter x, right? Very good. Ask yourself, what is the highest power of x in this case? The highest power of x is what? Is 1. So this is a linear equation. All right. So whenever you have this type of linear equation, this is very, very important. Please take notes. Whenever you have this type of linear equation, and your variable is in form of a fraction. Can you see that your variable is x and is in form of a fraction, right? Good. You will have to solve it in either of the two ways we'll be learning now. The first way you could solve it is to cross multiply, okay? Is to cross multiply. If you don't know how to cross multiply, you can check the videos on my playlist in the Mathematics Made Easy series that I've made. I've taught cross multiplication, but I'll still be fast about it here. When you cross multiply, it simply means the numerator here will multiply the denominator here. The numerator here will multiply the denominator here. That's what it means to cross multiply, okay? So when you cross multiply, 2 will multiply x, that will give us 2x. Then you write down the equality sign. 10 will multiply 5, that will give us 50. So 2 times x is 2x. This equality sign is this equality sign. 10 times 5 is 50. So this is how to cross multiply, okay? Remember this stage we have learned in mathematics, that when we are looking for a variable and the variable is frozen to a constant, which is the coefficient, we have to divide both sides by the coefficient of that variable, which is what? 2. So we divide both sides by the coefficient of what? X. We are doing very well. Okay, so we'll have 2x divided by 2 equals to 50 divided by 2. Okay, so 2 can cancel 2, freeing up x to be equals to what? 50 over 25. So if we like, we can cancel 50 with 2 here so that we'll have 25. Or if we like, we can bring down 50 over 2 and cancel it later. Whichever case you are more comfortable with is fine. So in this case, we have cancelled it directly. So 2 cancel 2 will free up x, giving us this x here. This equality sign is this equality sign here. And when 2 goes into 50, we have 25. Easy peasy, right? Very good. Alternatively, there is another way you can solve this same problem, okay? Now, this is the same equation, right? We want to solve it with an alternative method. Take note, there is always a good reason why I do certain things, okay? You will soon see the reason why I'm bringing out this alternative method of solving problems of this nature, okay? All right. Alternatively, you will take the LCM of the denominators. These are the denominator. This is a fraction, right? And this is a fraction, right? This is the denominator of this fraction, which is 10. 2 is the denominator of this fraction, which is what? 5 over 2, okay? Now, if you're having issues with taking LCM or finding LCM of numbers, check my playlist. You would see a video where I taught how to take LCMs, okay? So when you take the LCM of 2 and 10, it will give you 10, okay? The LCM of 10 and 2 or 2 and 10 will give you what? 10. Now, the next step is to multiply both sides. When we say both sides, we mean the left-hand side and the right-hand side. So you are going to multiply both sides by 10, which is the LCM you have gotten, okay? In other words, we'll multiply the left-hand side by 10, which is the 10 we have here, multiplying the left-hand side. I'll multiply the right-hand side by 10, which is 10 we are having here, okay? So when you multiply like this, we can see that this 10 can cancel this 10 to free up x, right? Yes. And this 2 can go into 10 to give us what? 5. So when 10 goes into 10, you have a 1. That is the reason why we're having 1 here. And we're having x, right? Very good. This equality sign is the same equality sign you have here. When 2 goes into 10, you have what? 5. That's the reason why you're having this 5 here. And this other 5 is the 5 you're having here before now. So in mathematics, bracket means multiplication. Bracket means what? Multiplication. This simply means 1 times x. That will give us x, because we don't like writing 1x in mathematics, okay? Then 5 times 5 will give us what? 25. So we have 1 times x equals to 5 times 5. 1 times x is x. 5 times 5 is 25. Can you see that this is the same answer we got when we used the first method earlier on? All right. So for me, I personally recommend this method. You will know why as we proceed. I personally recommend this method. So what's the method I've recommended? You take LCM of the denominators and you multiply through by what? The LCM. All right. Now, take a look at this example. We have 3x over 4 minus 7 over 3 equals to 17 over 12. Don't let this question scare you. Don't be afraid. It's as simple as anything, okay? Don't let it scare you. The first question you should ask yourself is this. Is this a linear equation? Yes, it's a linear equation. Why? Because number 1, there is an equality sign. Then number 2, our variable, which is x, the power is what? 1. So this is a linear equation. Don't let the fraction scare you, okay? All right. We'll start by reproducing the equation we have been given, right? Very good. Now, whenever you have your variable in form of fractions like this, remember I said you could start by saying cross multiply, or you could do what? Use the alternative method, which is what? Take LCM of the denominators. The reason why I prefer that second method is for problems like this. It's easier when you use that method for complex problems, just like this now, okay? Especially when your variable has to do with fractions, okay? So in this case, just like we did in the previous example, we will take LCM of the denominators, which are what? 4, 3, and 12. The LCM of 4, 3, and 12 will give you 12, just like we did before, right? Very good. What's the next thing you do? The next thing you do is to multiply both sides by what? The LCM, which is 12. Multiplying both sides means multiplying the left hand side and the right hand side. The same thing as saying multiply through by 12. That is what some textbooks will tell you. Okay? So multiply both sides by what? 12. When you multiply both sides by 12, it simply means that 12 will multiply this first fraction, which is why we have 12 here, and we have used this bracket to mean multiplication. Okay? The minus sign you have here is the same thing as the one you have here. You can see 12 multiplying this 7 over 3, and you can see 12 multiplying even the right hand side. I hope it's clear, right? Very good. The next step is to divide through. Okay? 4 can divide 12 how many times? 3 times. So we end up having 3 into bracket x here, right? 3 can divide 12 how many times? 4 times. We end up having what? 4 into bracket 7, right? Very good. And 12 can divide 12 one time. We end up having what? 1 times what? 17, right? Very good. So that's the reason why we now have 3 here, 4 here, and 1 here. Because 4 into 12 is 3, 3 into 12 is 4, 12 into 12 is 1. It's simple, right? Very good. So we've already said before now that bracket means multiplication. So 3 times 3x will give you 9x. 4 times 7 will give you what? That was 28. And 1 times 7 will give you what? And 1 times 17 will give you what? 17. Okay? I believe it's clear up to this stage, right? Very good. All right. So at this point in time, what do? We've already learned how to solve this type of equation in our first 2 examples, right? Very good. Can you see that in mathematics, the stages you've learned before, they keep on having a way of repeating themselves. That's the reason why we have come to this same stage that we've learned before. So what do here? We collect like terms, because constant are like terms, right? And we love moving constants to the right hand side. 17 is already on the right hand side, so it is minus 28 that will cross over to come and marry up with 70, right? Bravo. All right, collect like terms. So 9x remains at its position, 17 remains at its position. Now take note, minus 28 crossed over. Don't write minus 28, so it has to change to plus 28. Very good. So 9x equals to 17 plus 28. Add up 17 and 28, you will have 45, okay? We now have 9x equals to 45. Remember that we have learned how to solve this stage in mathematics, right? Yeah. So what do at this stage? We divide both sides by the coefficient of x, which is what? 9, okay? So we end up having 9x divided by 9 equals to 45 divided by what? 9. All right. So x, in this case, 9 is equals to what? 9 into 5, 45 is what? 5. 9 cancel 9 is x. 9 into 45 is 5. As you can see, I've written the value of my x directly. In the previous examples, I used to bring down this 45 over 9. So it's a matter of choice. Whichever way you do it, you are right, okay? Okay. Now, how about this example? 3x minus 1 over 4 minus 2x minus 1 over 3 equals to 1. Don't get scared. It's all the same. It's simple as anything you can think of, okay? So it's the same thing. You start writing your solution, you reproduce the question you have been given. First of all, is this a linear equation? Yes, it is, because number 1 is an equation because of this equality sign. Number 2, the variables we are having is what? The variable is what? X. The power of x is 1, power of x is 1, so this is a linear equation for sure. Okay, we've already established that whenever our variable is in form of fractions like this, what do? We prefer taking LCM of the denominators, okay? After taking LCM of the denominators, we prefer using that LCM value to multiply through, all right? Okay, so you might want to ask, the denominator here is 4, denominator here is 3, what is the denominator here? Or why is 1 not a fraction? Whenever you have whole numbers like this and you have some other numbers as fraction, you can simply make this one a fraction by saying divided by 1. So the denominator of this one is what? 1. Even if it were 20, even had it been we had a 20 here, the denominator will still be what? 1. Okay? So we are taking the LCM of 4, 3, and 1. Okay? So, okay, good. We can try to write out all the numbers as fractions first to avoid confusion, just like I've said earlier on. So Had it been we had the 20 here, we could have written the 20 here. Okay? So that's the same way we have written 1 over 1. So you take the LCM of 4, 3, and 1. LCM of 4, 3, and 1 is what? 12. So what do you do next? You multiply through by this 12. Okay? So you multiply both sides by 12, or you multiply through by 12, whichever phrase is convenient for you. So you can see that the 12, we are using it to multiply the 3x minus 1. We are using brackets to mean our multiplication, just the same way we did in previous examples. I hope this is clear, right? There is nothing new here that we have done, that we have not done before now, okay? All right, so when 4 divides 12, we'll have a 3. When 3 divides 12, we'll have a 4. And when 1 divides 12, we'll have a 12. So this 3 is because we divided 12 by 4, so 4 in 12 is 3. The 3x minus 1 is the 3x minus 1 we have written here. This minus sign is this minus sign. 3 into 12 is what? 4. The 2x minus 1 remains our 2x minus 1. 1 into 12 is 12. Okay? Alright, we can as well write 12 bracket 1. Okay? But I've decided to leave it out because anything times 1 is that same thing. Okay? But if it's convenient for you, you can write bracket 1 at this stage, so that when you multiply through, the 1 will go. Okay? Alright. So we've already established that bracket means multiplication, right? Very good. 3 times 9x will give us 9x. 3 times 1 will give us 3, okay? So 3 times 9x is giving us 9x. 3 times minus 1 is giving us minus 3, okay? Now, be very careful here. We are moving to the next one now. 4 times 2 is not just 4 times 2, is minus 4 times 2, 2x. That will give us minus 8x. Now, this is where you should be more careful. The next multiplication we want to do now, which is minus 4 times minus 1. Okay? Minus 4 times minus 1. I have my reasons why I'm repeating this particular one, because this is where most students or pupils make mistakes in mathematics. It is minus 4 times minus 1. So, the minus times minus will first of all give you a plus. Okay, then 4 times 1 will give you 4. Okay, now this is the equality sign, and this is the 12. I hope it's clear. So what we have done here is what we refer to as expansion. We have just expanded this fraction by removing the brackets. Okay, all right, good. At this stage in mathematics, the first thing you want to do is to rearrange. When I say rearrange, I don't mean collect like terms. Rearrange in that you can see that our variable here, we have 9x here, we have 8x here. They are similar items, right? They are similar. Since they are both on the left hand side, it's not as if one is on the right hand side and one is on the left hand side. They are both on the where? On the left hand side. We just want to bring them closer to themselves. We are not collecting like terms yet. No one is crossing over yet. So it simply means that plus 9x will maintain its sign as plus 9x. Minus 8x will still maintain its sign, because it was not as if it crossed from the right hand side to the left hand side. It was already on the left hand side. So we are just rearranging. Take note, we are just what? Rearranging. Similarly, minus 3 and plus 4, they are constants. They are on the what? They are on the left hand side. Since I'm rearranging, I'm not moving them yet. I'm just bringing them closer to themselves. So minus 3 will still remain minus 3, plus 4 will still remain plus 4. Take notes. I've decided to bring it to this next page so that we can have a very clear understanding, okay? Okay, so what we'll do, what? We'll rearrange. So rearrange the equation. So by rearranging, just like as I've said, 9x remains 9x. This minus 8x remains minus 8x. Minus 3, I've brought it closer to what? Plus 4. And is equals to 12. I have not collected like terms. In other words, none of them has crossed the sign of equality to change sign. I just brought brothers to brothers. Okay? Like terms together. So 9x minus 8x will give us 1x. But we'll prefer to write it as x. Take notes. Minus 3 plus 4. Take note that I did not just say 3 plus 4. I said minus 3 plus 4. If you are not careful with this minus sign, you will make a lot of mistakes. That is the reason why I took my time out to make a video on the confusing minus sign in mathematics. It's on my playlist. If you're having issues with minus sign, check my playlist. You have a very good understanding, because this minus sign has a way of destroying or making you make a lot of mistakes in mathematics. All right, that's by the way. So 9x minus 8x will give us 1x, which is same thing as x. Minus 3 plus 4 would give us plus 1. If you are wondering how it will be plus 1, go and check that video. Very, very important. All right, so 9x minus 8x is 1x, and minus 3 plus 4 is plus 1, equals to 12. Okay, now we can do what? Collect like terms, because we have a constant here, so this plus 1 will have to move over to the other side to become what? Minus 1. So collect like terms, right? Okay, so when we collect like terms, our x now will be what? 12 minus 1. Our x will be equals to what? 11. Very good. All right. So there is a bonus tip for you. The bonus tip here is how to check your answer. In other words, whenever you solve any equation, you can always plug in those values of x or values of y or m that you have gotten into the equation to know whether you are right or wrong. We'll learn this tip by solving for x in this equation. We have 2x plus 5 equals 25, right? So I will start by solving this equation. When we've gotten the value of x, we'll test our result to see whether our answer is right or wrong. Okay, so what do we do here? We collect like terms, right? So how do we collect like terms? This is a constant. It's already on the right hand side. So we move plus 5 to marry up with it. It becomes what? Minus 5. Take notes. So we now have 2x equals to what? 25 minus 5. Okay? So we now have 2x equals to what? 25 minus 5 will give us 20. So what do we do at this stage in mathematics? We divide both sides by the coefficient of x, right? You write divide both sides by the coefficient of x. Very good. So when you divide both sides by the coefficient of x, 2 we cancel 2, leaving us with x, and 2 we cancel, we go into 20 how many times? 10 times. So x is equals to 10. Now that we've gotten the value of x, let's check our answer. The equation is 2x plus 5 equals 25, right? This is the equation we are given, and this is it. So in order for you to check your answer, all you need is the left-hand side of the equation, which is what? 2x plus 5. So whenever you want to check your answer, forget about the right-hand side. You are interested in the left-hand side first, okay? We want to put in the value of x here to see whether you will have 25 as your answer. So this is the left-hand side, 2x plus 5, right? Which is the left-hand side. That's what we are interested in. So you substitute our value of x, in this expression. Remember that our value of x that we got was 10, right? So in place of x, put 10 there. So we now have, instead of having 2x plus 5, we'll have 2 into bracket 10 plus 5. Remember that bracket means multiplication, right? So this simply means 2 times what? 10 to give us 20, right? 2 times 10 is 20 plus 5, 25. Since we got the value on the right side by substituting our value of x on the left-hand side, our answer is what? Correct. I hope you have learned this tip. You can apply it to any other type of equation, okay? Now you can try the following problems. Solve the following equations. There are just 3. When you are done, you can write your answers in the comment section. If there is any part of this tutorial that you don't understand, you can leave your comments in the comment section. I'll take my time to respond to it. And if there is any topic in mathematics you want me to make a tutorial on, let me know in the comment section. So there are more important lessons or interesting lessons that will be coming our way. We will be learning quadratic equations later, simultaneous equations, bearing and distances, probability, longitude and latitude, graphs, and so much more. So if you haven't subscribed, I will strongly suggest you like, subscribe, press the bell icon so that you can be notified anytime any of these interesting videos are ready. Thank you for listening. Till we meet again.